A snake the size of a fire hose vanished from a Florida swamp, and the only thing left behind was a heartbeat that wasn't its own. Somewhere under the black water of Big Cypress, a small transmitter kept sending out its steady electronic pulse, ping, 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 exactly the way it was built to do. The problem was, the python wearing that transmitter should have been dead weight by now, sitting still, doing nothing. Instead, the signal was moving, slowly but moving, gliding through mud and root and standing water as if the python had grown legs and decided to go for a walk. Wildlife biologist Ian Bartoszek stared at the screen and felt his stomach drop because he already knew what a moving signal like that usually meant. Something had eaten his python whole, transmitter and all, and that something was still alive, still digesting, still out there in the swamp he had walked through 1,000 times without ever noticing it. This is the true story of how one of the most hated invaders in American history, a snake so destructive it wiped out entire populations of native animals in a matter of years, finally ran into something in the Everglades that could actually stop it. Not a bigger predator flown in from overseas, not a government program with millions of dollars behind it, something that had been living in that same mud the entire time, ignored, underestimated, and completely capable of doing what alligators, panthers, and human hunters with machetes could not. Bartoszek runs the Python program for the Conservancy of Southwest Florida, and for years his job looked almost boring on paper. Catch juvenile Burmese pythons, surgically implant small radio transmitters inside them, release them back into the swamp, and track where they go. The idea is simple. Young pythons, especially males, will eventually find their way to a breeding female, and if researchers follow that signal, they can find nests loaded with dozens of eggs before those eggs ever hatch. It is slow, wet, mosquito-bitten work. Chest-deep water, sawgrass that cuts like paper, heat that presses down on you like a hand. Nobody imagined it would turn into a murder investigation. The first strange case involved a young python the team had nicknamed by its tag number. For weeks, its signal behaved exactly the way a healthy snake's signal should, moving through territory, settling into resting spots, occasionally shifting position the way a python does when it is hunting or digesting a meal of its own. Then one day the movement stopped completely, not the gentle stillness of a snake resting in the sun. A total, permanent stillness. Bartoszek and his team waded out to the coordinates, expecting to find a carcass, maybe evidence of a fight, maybe nothing at all if the transmitter had simply failed. What they found instead was almost worse than a body. There was no blood, no torn skin, no drag marks through the mud, no sign that any struggle had ever happened. Just a faint, steady beep coming from somewhere that clearly was not a python-shaped animal anymore. A few months later it happened again, then a third time. 3 separate pythons, 3 working transmitters, and in every single case, nothing left behind to explain where the snake had gone. The team started running X-rays on the few unidentified animals they eventually managed to recapture near those coordinates, and the images made everyone in the room go quiet. There, curled inside the stomach of another animal entirely, was a python's spine, and right next to it, still intact, the transmitter that had led them there in the first place. One case involved a python that measured close to 13 feet and weighed over 50 pounds, an animal plenty big enough to be considered an apex predator in its own right. It had been killed and swallowed whole. Bartoszek later called it one of the strangest moments of his entire career in the field. To understand why this discovery hit the research world so hard, you have to understand just how badly Burmese pythons had already beaten every other defense Florida tried to throw at them. These snakes are not native to any part of the Western Hemisphere. Their real home is Southeast Asia, in the swamps and forests of Myanmar, Thailand, Vietnam, and Indonesia, ecosystems that spent millions of years building a natural braking system around them. Tigers hunted them, king cobras hunted them, large monitor lizards raided their nests, parasites and diseases kept their numbers in check. Every predator, competitor, and pathogen in that part of the world had evolved side by side with pythons, learning how to survive them without being overrun. None of that evolutionary history made the trip to Florida. Starting in the 1970s and accelerating through the 80s and 90s, the exotic pet trade brought thousands of baby Burmese pythons into American homes. They were cheap, they looked impressive, and at 12 or 18 inches long, they seemed manageable. Then they grew and grew until a snake that started life in a small glass tank was pushing 15, 18, 20 feet long and eating an entire chicken in one sitting. Plenty of owners panicked and did the one thing you should never do with an invasive species. They drove out to a canal or a patch of wetland and let it go, assuming nature would sort it out. Nature did not sort it out because there was nothing in that ecosystem built to stop a 20-foot ambush predator. Then, in August 1992, Hurricane Andrew tore through South Florida as a catastrophic Category 5 storm, flattening whole neighborhoods and shredding commercial buildings across Homestead. Among the buildings destroyed were several reptile breeding warehouses, and the storm didn't just release a handful of escaped pets. It dumped a large breeding age population directly into prime python habitat in a single night. What had been a slow trickle of accidental releases turned into a flood. The destruction that followed reads almost like a wildlife apocalypse. Long-term surveys of areas with heavy python activity found raccoon numbers had collapsed by more than 99%. Opossums fell by almost the same amount. Bobcat populations dropped by close to 90%. Marsh rabbits and cottontails all but disappeared from large stretches of the Everglades. Researchers pulled the remains of dozens of different bird species out of python stomachs, including migratory birds that had flown thousands of miles down from Canada, expecting a safe place to spend the winter. Deer, raccoons, even full-grown alligators showed up as meals. One python captured by the Conservancy team in 2024 weighed 115 pounds and had swallowed a 77-pound deer, nearly two-thirds of its own body weight, in a single meal. Every tool the state of Florida had access to got thrown at the problem. Importing the species became illegal. Pythons were classified as a federally regulated invasive species. Trained detection dogs learned to sniff out python scent trails. Thermal drones scanned the sawgrass from the air looking for heat signatures. Every year, the Florida Python Challenge draws hunters from across the country for a 10-day hunt, complete with cash prizes reaching into the tens of thousands of dollars. The Conservancy's own team has personally removed more than 53,000 pounds of python, along with over 25,000 eggs, from roughly 200 square miles of habitat since 2013. 20 tons of snake gone. And still, it wasn't close to enough. The Everglades system these pythons call home stretches across nearly 8,000 square miles, which means even the Conservancy's impressive numbers only scratch one small corner of it. Scientists who have spent decades on this problem started using words like unwinnable in private conversations, even while writing hopeful language into their public grant reports. A python can compress its body flat against the ground and disappear completely against a tangle of roots and dead leaves. Researchers have described walking within arm's reach of a fully alert, coiled python and seeing absolutely nothing. Add in a reproductive strategy where a single female can lay anywhere from a dozen to over 35 eggs at once, incubate them for 2 months by physically shivering to generate body heat, and reach breeding age herself within 3 to 4 years. And you have an animal that multiplies faster than any team of humans could ever hope to remove it. So when the transmitters started going dark, and when it became clear something in the swamp was killing and swallowing pythons whole, researchers scrambled to figure out what it was, because if there was a native predator capable of fighting back, that changed everything. The obvious suspects got ruled out fast. Alligators were the first guess, but alligators don't swallow prey cleanly. They death roll, tearing flesh apart and scattering the pieces, and they leave behind exactly the kind of mess that was missing at every one of these scenes. Florida panthers bite through the skull or spine and leave puncture wounds and claw marks, none of which were present. Black bears are strong enough to kill a large snake, sure, but bears tear their food apart with their paws. They don't calmly swallow a 13-foot animal in one continuous motion. Whatever was doing this had eaten its prey the way only one type of animal eats, head first or tail first, whole, without leaving a single bone out of place. That meant the killer itself had to be a snake, and according to every model researchers had for the size and strength of native Florida species, no snake in that ecosystem should have been capable of swallowing prey that large. The math said it was impossible. The evidence said it had already happened 3 times. Determined to get an answer, the team set up trail cameras at every location where a signal had gone dark and waited. Weeks passed with nothing but footage of wind moving through sawgrass and the occasional wading bird. Then, one morning, a researcher pulled up a new clip and the room went silent. On screen was a thick, dark, heavy-bodied snake lying almost invisible in the leaf litter at the water's edge, its color matching the rotting vegetation around it so perfectly that even a trained eye could barely pick it out. It wasn't hiding out of fear. It was waiting, positioned exactly where a smaller snake moving along the shoreline would have to pass within striking range. Then it struck, a blur too fast for the naked eye to fully register, and within seconds, it had clamped onto a juvenile python and begun the long, mechanical process of unhinging its jaw and walking the entire body down its throat, an act that took over an hour to finish on camera. The predator was a Florida cottonmouth, a native pit viper that had been living in those same wetlands for longer than humans have kept written records, an animal every single member of that research team had almost certainly stepped past on the trail without a second thought 100 times before. Once you understand what a cottonmouth actually is, the surprise starts to fade. Adults typically run 30 to 48 inches, though larger individuals can push past 6 feet, and they are dense, heavily muscled animals built for exactly the kind of flooded, low-visibility terrain that pythons had colonized when they invaded Florida. That dramatic open-mouth display cottonmouths are famous for, showing off the stark white lining that gives them their name, is really just a warning sign? The actual weapon is something you can't see at all. Cottonmouths are pit vipers, meaning they carry heat-sensing organs between their eyes and nostrils capable of detecting infrared radiation down to a fraction of a degree. Darkness doesn't matter to a sense like that. Camouflage doesn't matter either. Even a cold-blooded python that's slightly warmer than the surrounding water after resting in the sun gives off enough of a thermal signature to be found. Then there's the venom itself, a mix of enzymes designed to break down blood vessels and destroy tissue from the inside out. For smaller prey, a single bite is often fatal within minutes, and the venom begins breaking down muscle and organ tissue well before the meal is ever swallowed, meaning the cottonmouth is effectively dissolving its prey from within even as it eats it. Researchers on Bartoszek's team confirmed cottonmouths regularly hunt at least 27 different snake species as part of their normal diet, including other cottonmouths. Eating snakes isn't some new trick they picked up because of the python invasion. It's what they have always done. Pythons simply got added to a menu that was already long. Against something the size of an adult 20-foot python, a cottonmouth would stand no chance, and it knows better than to try. Its strategy against dangerous prey is strike and retreat, a single precise bite followed by immediate withdrawal, letting the venom do the actual work while the snake waits safely out of reach. That approach doesn't work on a fully grown constrictor with enough muscle mass to be nearly invulnerable in that ecosystem. But juvenile pythons, the 18-inch hatchlings just beginning life in a brand new environment, haven't built any of that crushing strength yet. To a cottonmouth, a baby python is just another snake, and cottonmouths eat snakes. What really stunned the research community was learning the cottonmouths weren't fighting this war alone. Once biologists went back through years of tracking data with fresh eyes, a pattern emerged that had gone completely unnoticed. Out of 19 monitored pythons in one particular study group, 5 had been killed by American alligators, and not just the giant 13-footers researchers assumed were the only gators big enough for the job. One of the kills came from a gator measuring roughly 9 feet, well within a size range scientists had previously written off as too small to take on a large python. Video evidence backs this up too. In 2024, a large alligator nicknamed Godzilla by locals was filmed hauling a massive python through the water in the Everglades, and similar footage has surfaced in years before and since, including a 10-foot alligator caught on camera in 2023 eating a large python outright. Alligators, it turns out, had been quietly pushing back against the invasion the entire time, and nobody had been counting. Then came a moment with no precedent anywhere in the scientific record. In June 2021, wildlife cameras captured a bobcat directly attacking a nesting female python, an animal many times the bobcat's own size. It wasn't scavenging abandoned eggs. It slashed at the mother with its front paws, drove her backward through sheer aggression, and then methodically raided the nest, taking eggs one at a time, while keeping the much larger snake at a distance. No bobcat's ancestors had ever encountered a Burmese python before, which means there was no instinct passed down for this exact situation. The behavior had to be learned, worked out, and executed within a single animal's lifetime. One researcher who reviewed the footage said simply that the bobcats had figured it out before the scientists did. Similar bobcat and python nest confrontations have since been documented again, confirming it wasn't a one-time fluke. The list kept growing from there. Owls and hawks have been filmed picking off juvenile pythons caught in exposed positions at dawn and dusk. Gulf Coast indigo snakes, another native species, have been documented preying on pythons as well. Even a Florida king snake was recorded swallowing a hatchling python whole, the first observation of its kind ever published. Black bears in Florida, panthers have separately been recorded, taking pythons when the opportunity arose. None of these animals were coordinating with each other in any way. A pit viper striking in the leaf litter, a raptor pulling a juvenile from a branch, an alligator ambushing from the shallows, a bobcat raiding a nest, a king snake swallowing a hatchling. All of them acting completely independently, all of them converging on the exact same target, doing exactly what millions of years of evolution had shaped them to do the moment a new competitor showed up in their territory. But here is the hard truth researchers still have to sit with. It isn't close to enough yet. A single female Burmese python can lay well over 30 eggs in one clutch, and she will coil around that nest for up to 70 days straight, shivering her body to generate warmth without eating a single meal the entire time, defending those eggs with the full strength of an animal that can weigh over 200 pounds. These snakes reach breeding age within 3 or 4 years and can live 2 decades or longer, meaning each new generation is already setting up the next one before the current generation has even finished growing. For every juvenile a cottonmouth manages to catch, for every nest a bobcat manages to raid, dozens more eggs are hatching somewhere else across a landscape too vast for any research team to fully patrol. Human effort has made a real dent. More than 5,000 pythons have been pulled out by licensed hunters since Florida's removal programs began, and the annual Python Challenge, alone eliminated nearly 200 snakes in a single 10-day stretch during 2025. The Conservancy's own long-term monitoring is starting to show encouraging signs, too, reporting that the male scout snakes they track are increasingly struggling to locate mates, and that the breeding females they do find tend to be smaller than the record-breaking giants captured in years past. Evidence the population's growth may finally be slowing in the areas under the heaviest pressure. But pythons are also expanding into new territory, with sightings now showing up more than 100 miles north near Lake Okeechobee, a reminder that this fight is still spreading even as it's being fought back. What keeps biologists like Bartoszek checking their monitors with such focused attention isn't just curiosity anymore. It's something closer to watching a slow-motion war play out in real time, one flatlined signal at a time. Every dead transmitter raises the same question. What got this one this time? Every X-ray pulled from a cottonmouth's stomach, every set of tracks left in the mud beside an alligator kill site, is one more small piece of proof that the ecosystem hasn't given up defending itself, even without any help from the researchers standing nearby with their notebooks and antennas. Nobody in the scientific community can say for certain yet whether native predators will ever catch up to a species that reproduces this fast, or whether these newly learned hunting behaviors will get passed down through enough generations to actually bend the population curve downward over time. What they can say is that the fight isn't waiting for anyone's permission. The cottonmouths didn't wait for a research grant to start hunting pythons. The bobcats didn't wait for a management plan before raiding a nest. The alligators just kept being alligators, quietly doing what they have always done. While government agencies were still coordinating budgets and permits, the swamp had already started fighting back on its own. There's another layer to this story that rarely makes it into the headlines, and it has to do with just how strange it is for a cottonmouth to attempt something like this in the first place. Swallowing prey that is nearly as long as your own body is not a casual decision for a snake. The jaw has to unhinge far beyond its normal range. The throat muscles have to work in slow, rhythmic waves to pull the prey inward inch by inch. And the whole time, the predator is completely vulnerable, unable to strike, unable to flee quickly, unable to defend itself if something bigger happens to wander by. A cottonmouth that commits to swallowing a python this size is making a bet with its own life, betting that nothing will interrupt it during the hour or more it takes to finish the job. That a cottonmouth is willing to take that risk at all tells researchers something important about how much pressure this invasion has actually put on the native food web. When easy prey becomes scarce because raccoons, rabbits, and marsh birds have been wiped out across huge sections of habitat, predators start taking chances they otherwise wouldn't. That idea that the whole ecosystem is being forced to adapt under pressure shows up again and again once you start looking for it. Wildlife biologists have pointed out that this kind of rapid behavioral shift, a native predator adding a brand new prey species to its diet within a matter of years, rather than over evolutionary timescales, is exactly the kind of resilience conservationists hope to see, but rarely get to actually document happening in real time. Most invasive species, stories end with the native wildlife simply disappearing, unable to respond fast enough to a threat their bodies and instincts were never built for. The python invasion looked like it was heading that exact same direction for years, watching mammal populations crash by staggering percentages with seemingly nothing standing in the way. The fact that cottonmouths, alligators, bobcats, king snakes, and birds of prey all independently found a way to strike back without any human intervention teaching them how is being treated by some researchers as one of the more remarkable examples of natural ecological pushback ever caught on camera. None of this means the story has a tidy, happy ending yet. The population numbers still tell a sobering story. Even with 20 tons of python physically removed from the ground since 2013, even with drones, dogs, hundreds of volunteer hunters, and a small army of native predators all working the problem from different angles, estimates for the total wild population still run into the tens of thousands. And some researchers believe the real number could be far higher, once you account for the vast stretches of habitat nobody has ever been able to properly survey. Helicopters can scan a lot of ground, but a python pressed flat against a root system in ankle-deep leaf litter can be invisible from 30 feet in the air. Thermal cameras help, but a snake that has just eaten a meal and cooled back down to the temperature of its surroundings can slip past even the best infrared equipment. This is, in the most literal sense, one of the most difficult removal problems wildlife management has ever faced anywhere in the world, made only slightly less impossible by the fact that the swamp itself decided to start fighting back. What makes Bartoszek's radio tracking data so valuable isn't just that it revealed the existence of these predators. It's that it gave researchers a way to actually measure something that used to be invisible. Before those transmitters started going dark inside cottonmouths and alligators, there was no real way to know how often this kind of predation was happening. A python simply vanishing from a survey area could mean 100 different things: migration, an equipment failure, a slow death from disease, or a kill that left no visible trace behind. The transmitters turned every disappearance into a solvable case, a signal that could be physically walked down and confirmed. And confirmed cases are exactly what turns a hunch into real science. Every new transmitter recovered from inside a predator's stomach adds one more confirmed data point to a picture that took years to even start coming into focus. And the Conservancy has continued expanding that tracking network specifically because of how much these accidental discoveries have taught them. Somewhere out in the Everglades tonight, under cypress roots and black water, a cottonmouth is digesting a meal it was never supposed to be capable of catching. Its stolen transmitter still pulsing away, still proving that the animal it belonged to is gone. Not far from that same spot, a fresh clutch of python eggs is getting ready to hatch, restarting the exact same fight all over again. This war in the swamp is nowhere near finished, and the next discovery could rewrite what scientists think they know about who is really winning it.